Today we're walking through one of the most intense and energy efficient HVAC systems we've ever installed. It's what keeps this multi-million-dollar home comfortable year-round. We're going to talk about all of the hidden ductwork, the advanced controls, and everything that goes into keeping this home the perfect temperature year-round and doing so efficiently. And with me is the team from AGS. One of the things that we started with on this project was a team. And that team was you guys, Mitsubishi, and Homans.
Correct.
And before we touch this project, before we consider what it's going to take, we need to understand the science of the building. Walk me through why that's important.
Normally when we do a house and we're looking to heat and cool the house, the first thing you want to do is heat load. You want to make sure we got the proper amount of BTUs in heating and cooling.
Now, when you say heat load, that is primarily because we're in a heating dominant climate zone.
Correct.
So if we were in Texas, it would be like we would be looking at cooling load first, but in Massachusetts, we're looking at heating load first.
That is correct.
What does that study look like? What are you paying attention to in terms of how much BTUs this house really needs?
We're looking at insulation, how thick the walls are, what type of insulation we're using. Windows, very important. How much heat loss gain do we have through there? It's critical that we're doing a proper heat load. We want to make sure that the sizing of the equipment is right. A lot of guys will oversize for the heating part of it, especially with a heat pump. But the cooling side of it, the bad part about that is if we're oversizing it and it's not sized properly, what are we going to run into? Humidity problems, short run times. Today with the systems that we're doing in most houses, it's more about a longer run time at a lower speed, and that's really where we're getting our energy savings from. But if we're doing a proper heat load, we don't need to oversize or undersize when it comes to a home.
What happened here is, as you see behind us, we have this one, we have a large door there, and then 3, 4, 5 more large panels. This first floor is, I think it's more than 50% glazing.
Correct.
So we had this massive solar heat gain. This side particularly was driving up our cooling load. We almost accepted that.
Yeah.
We almost said, all right, just put the bigger equipment in. In one of those meetings, someone said, well, what would be required for us to reduce our cooling load? And they said, if you could change the glass to a higher performance glass,
correct,
we could reduce the cooling load.
Correct. So
So I called the glass manufacturer and he goes, I'm literally about to order the glass.
Yep.
If you can change this spec to this spec, what's the delta for that? It was like an $8,000 charge, which was far less than the equipment upcharge on it. And we changed the glass on these units that face the backyard.
Yep.
And we were able to reduce our cooling load by 50%.
Correct.
And that was huge because you
was huge.
You would have had a system that was adequately sized for the cooling, but it was way oversized for heat.
Correct.
One of the things that we said is we want to work with Mitsubishi on this primo product that we install in our homes.
It's the best equipment out there.
What did we end up in terms of outside units, inside units, zones? How does that all work?
2 outdoor units, multi-zone systems. Got a mixer box downstairs. We got 7 units total.
And the outside units they're not condensers, they're heat pumps.
They are heat pumps.
And it's an air source heat pump. You have 2 of them.
Correct.
That go into 2 branch boxes and then split amongst the 7 indoor units.
That is correct.
The size of the home, it's over 7,000 square feet.
Yep.
We have 2 outside units. When I tell people that, they're like, how many zones do you have? And it's, well, we have 7 zones. It's like, how are you accomplishing that? It comes back down to the fact that it's all engineered.
The builder, the plumber, the electrician, us guys, we're all getting together, we're having a conversation, and we're going on how we want to build this house. What do we need to do as far as adjustments to achieve everything that we need to achieve?
So we're standing here in the kitchen and I see you have these 3-inch Zender tubes. Right there it says kitchen exhaust. This is the first look at that ERV. We'll go down in the basement. We're going to meet up with Junior in a little bit and he's going to walk through the ERV system itself. This is where everything is coming out. These are extraction points, right?
Correct.
So in a kitchen area, you're typically just extracting because there's a lot of stale air, a lot of people hanging out, cooking. So you want to get air out of this space, but then you're going to be providing fresh air probably down in like the living room and things like that.
You want to provide fresh air where the living spaces are, bedrooms, basically where you're hanging out most of the time. Kitchen, you want to extract. Bathroom, you want to extract. Laundry room, you want to extract. Zender system is capable of doing that, where we have a certain amount of air always moving, always changing in the house. As bathrooms are being used, kitchens are being used, they're bringing that blower motor up in order to increase the air, whether they're extracting or they're putting fresh air in.
And when you say that, that's not automatic. That's actually done through a booster switch, which I notice here you have this control wire. And for the kitchen, we actually tucked it in the pantry here. So
correct.
If you need to be boosting that system, you come in here and flick that switch.
Correct. That's going to bring up the CFMs in the Zender, and we're going to be able to extract the air that we need out of the space.
And it's doing the same thing in the bathroom. I want to be careful to note that that doesn't replace a kitchen exhaust.
No, it doesn't.
So we have a kitchen hood here. It's not installed. We're obviously still under construction, but we have exhaust going out, but we need to bring air in. And that air coming in is makeup air.
Correct.
Can you walk me through what makeup air is and why it's important?
Well, if we're exhausting air or we're taking air out of the building and we're not putting it back in, where are we taking the air from? We're taking it from the Zender. We're taking it from the heating and air conditioning system, which we don't want to do. We want to keep that air in the building. The makeup air is going to make that up. So when that exhaust fan kicks on, that makeup air kicks on. Now we're just kind of, I don't want to say recycling, but we're putting that air back into the space.
Right.
So we're not stealing it from the heating and air conditioning or the ERV.
It's almost like trying to suck the air out of a deflated balloon.
Correct.
A typical detail for us in all of our projects is we do this hood within a hood, which is what we're doing here. Is so your exhaust air is going out,
Yep.
but we're bringing fresh air into the backside of the hood and filtering it, kind of like a commercial setup.
Correct.
So you're bringing your fresh air in, your kitchen exhaust is mixing with that fresh air, circulating and getting back up and out. There is no natural gas here, which is a good thing.
Yep. The most important thing here is we're not creating a negative pressure in the kitchen or in the house, and that we're not taking from the heating and cooling system. So that's why it's important that we do a makeup air.
We have ductwork in this house. So
Yep.
first floor here, where is our ductwork placed?
All underneath us. In any system, mini split, regular, conventional, you always like to put your supplies next to your windows. This is where your most heat gain and heat loss is, right
Yep.
here where your windows. So we always place our supplies as close to the window, depending on design, engineer.
I'll say it for the
design.
I'm also going to say
design part.
for the comments that looks like it's offset, but when it's final cut with our grill, it gets centered directly in the window.
Correct.
That's not a miss on our part. Definitely not a miss on AGS's
No.
part. We had some framing below there, but our grill actually will be centered on that. If you go throughout the whole space, we have these large windows. We only have these small registers in front of these essentially large doors and windows. How do we determine that that is enough for this space?
Well, when we do our duct calculations, that's what's going to tell us. We know the square area, we know how many BTUs that we need to heat that area. And when we do our duct calculations, that's going to tell us how many CFMs we need for each space. And then you want your returns in the center of the house so that we're pulling everything back to the center of the house.
Important note, we have it in front of the window of the stationary unit.
Correct.
You want to avoid obviously stepping on it
Right.
at the door.
So we don't put it in the moving part of the door.
And put your high heel through it, right?
Correct.
Or your work boot.
Correct.
So dining space here, we have this 25-foot ceiling. You have this a very challenging return
It was.
to accomplish. This is central to the first floor. So you're pulling, all of your supply air to the center. Kind of, is that helping distribute the temperature throughout the home?
It's helping distribute the temperature through, the air into the space. It's also giving us that even temperature throughout the house.
Got it. And what's the benefit of having it up high?
Your heat rises,
Yep.
cool air settles. So we're not at the highest point, we're kind of in the middle of the
Sure.
point. We're helping the heating and cooling part of that
Right.
out. Some instances you can't do that, you're doing a return on the floor, you're doing a return on
Right.
and it worked out really well where we're not way up high, but we're not really down low, we're in the middle, and that's where we want to pull the air from.
Let's go up to the second floor because
Sure.
I want to walk through the challenges that we faced up there. We have these really high ceilings, and you guys installed all of our supplies in the ceiling. I know a large part of that is due to we have really challenging ceilings on the first floor. So to get ductwork in, that would have been difficult. Is there anything to consider or be concerned with trying to supply heat up there and getting it to spread throughout the space appropriately?
It's the construction
Sure.
that kind of dictates to you as far as where your supply and your returns are going to go. If the ductwork is designed properly and installed properly,
Yeah.
as long as we're putting in the same amount of air and we're taking out the same amount of air, and where we're putting them, we're going to get that even temperature throughout the house.
Do you know how cold it is out today
About 27 degrees
with the wind chill?
with the wind chill.
And how warm do you think it is in this house right now?
It's probably about 72, 73.
And do we have the heating system running?
Not yet.
No.
I won't allow you to do that until all this is done anyways. So.
Well, let's talk about that, because we have one tiny little heater in the basement.
Yep.
That we are running, not even on a 100 amp panel at this
Correct.
point. I mean, I'm in a jacket. I'm actually sweating.
I'm not.
I think that plays a big factor into this location of registers. It's like, sure, like, is that the optimal placement? Probably not, but it works. And
Correct.
this house is currently being heated by a small portable temporary heater. When you flick on that system, like, you're gonna be in an even better situation. But you made a great point. You won't let me turn the heat on.
Yep.
Why?
You got all brand new ductwork up there. It's all clean. It's all, so if we turn it on during construction, all that, and we could put filters in the register boxes before it actually goes into the duct.
Once a week.
Right.
Yeah.
Because the house is built tight and so well insulated, that little heater downstairs does its job.
Yeah.
We know all the ductwork inside is clean. We're not turning it on and blowing dust into a brand new house that's been cleaned and ready to go. You saw your boards on the floor.
Yeah.
We're not allowing anything to go down there.
They're not a dustpan.
Correct.
Yeah. We're in the primary suite. You have register above here. Nothing on the small window, frankly, because we didn't need it. And then we have these ones above these larger windows. Talk me through the veining that's in the middle. I had shared this.
And you got quite a bit of response on it.
Quite a bit of response. Primarily what you're wasting clients' money and time. I didn't install these, but I can only imagine that probably added 3 minutes a box.
Sure. Round pipe is the best way to move air, right? Because air moves like this.
Yeah.
So anytime you get something like this, the air is going to hit that box, and then it's a lot of turbulence in there.
Right.
One, we don't want to hear this run, right? We just want to feel comfortable.
Yeah.
If there's any little detail that we can do to help airflow and bring it in, it's just that little extra step that's going to help us out in the long run.
Is it making a massive difference? No, but it's a micro detail that, might reduce the sound by a few decibels.
Correct.
And frankly, like, depending on who buys the home, they might care about that.
Correct.
One of the things that you were really adamant on is, like, understanding what our register detail is. And, like, these are all going to be built into our white oak ceiling, like small grooves. And you said, I need to know how big of a space that we're going to create. And we flipped the question back. Like, you tell me how many square inches we need. It's a mistake a lot of builders make, is they put really restrictive registers on top of their supplies.
That is one of the biggest things when we're building a home and designing a home. You get a lot of customers that do hardwood floors, that flush register that doesn't have an air performance on it. Each system that we got, a certain amount of CFMs that we need to be pulling out, a certain amount of CFMs that we're pushing out. And if we're not pushing that out correctly, we build static pressure.
Right.
We get a noisy system. We get the system that doesn't run efficiently, pressures are not correct. So it's important that we have a good airflow design with our registers. You are very good at working at that and understanding that.
Everyone's going to have a different assumption.
Correct.
And if we go into this and everyone is making assumptions, like, no one's going to be on the same page. Where it's like, you said, what are you planning on doing here? I said, I'm going to router it into the back of my white oak. And you're like, with how big of a bit? And I said, I think a 1/2 inch. And you're like, well, I'll make a box that I know I'll give you enough air for that.
Correct.
And we know that the system's going to perform. Hey, I got one more question. I want to head down in the basement and meet up with Junior. This space was interesting because we are 25-foot ceilings, and we were really concerned with heat capture. We have this really beautiful brick detail on the wall. How are we essentially dealing with any heat that gets trapped up there?
We have returns both from this system here and that system in order to extract the heat.
But you're running a return and we're putting it behind the shingle. So essentially the shingle will, there's enough undulation in it where air can passively make its way through. What's the downside if you don't deal with that heat capture?
That heat's going to stay right there. We want the air moving throughout the house.
Yeah.
Don't want to feel it. You just want to feel the temperature. You want to feel comfortable, but we need to move the air throughout the house. That's what's going to give us the even temperatures.
These are some of the most important decisions we're making in building a home. But at the end of the day, from a user's perspective, they don't want to think about it. They just want to know that the house is comfortable.
They want to go to the thermostat, touch it, maybe, their phone, or
it's like, if you can get a couple to decide, like, hey, 68 degrees, never touch it, like, that's great. And you set it, you forget it, and the system operates. And then from a builder's perspective, you want the climate in the home to maintain from humidity and everything else like that.
Correct.
So I'm gonna go downstairs. I'm gonna be Mike. You guys, did a killer job in the mechanical realm.
We enjoyed working with you, Nick.
I appreciate it. I appreciate the partnership and
No,
appreciate
absolutely.
the walkthrough.
It was great.
Awesome.
It was great.
Let's go see Mike Jr. in the basement. With the shape of the home and being an L shape, the mechanical room worked out really well. We're able to tuck it completely behind the garage. It did cost a lot of money to blast all this stone or hammer all this stone in the back, but it net us a really nice, oversized mechanical room. So joining me today is Mike Jr. from AGS. Mike, good to see you as always.
Good to see you too, Nick.
This is where everything really starts. We have different equipment throughout the home, but this is where the line sets come in. We have branch boxes, we have shutoff valves. Walk me through what we got going on and what it's doing really.
So when we first started off here and we were placing units everywhere, really we think about a few things. We think about our service guys, one, because we got to come here and service it after. So one thing we want to do is make sure that we can access the units more.
It's something that we think about and then it's like, yeah, but you know what?
It's an afterthought.
It's an afterthought, especially working in Boston when you're working in the city. It's like, where do you put an access panel? How am I going to service this equipment? Putting that as a priority only nets a better long-term result in how this stuff lasts.
Since we didn't have much room for ductwork, I think the Mitsubishi came in really handy with the PEADs, the high static pancake air handlers. Putting them up there, facing them a certain way, so that way when our service guys come through the hatch with their filters, that they're only taking the filters up there with them.
So you're talking about the units that are up in the second floor ceiling. We have a couple down in the basement, but these are not pancake units, right?
No, these are actually the SVZ's high static air handlers. So they're just like a regular conventional air handler, just mini split, and we can connect them right to our branch box too.
What does the high static mean?
The high static, just more airflow, so we can get more duct run out of them.
So you can really push air a lot further in the home.
Yes.
What are these servicing right now?
We got one servicing the dining area, and then the other one is the kitchen area.
And that's what we're under right now. We're
Yes.
underneath the kitchen and essentially dining spaces over there,
Yep.
which is why you see this running in that direction. These are your line set and they tie back to your branch box. What is all this? This is not something that you typically see in residential construction. So what is it and why is it important to you guys?
We decided to do this because if we need to work on the unit in future, from here we can isolate the system and still having the system run while just working on that one unit. So here we can just shut off each one, depending on which one is connected. And, let's say like this one right here is connected to the downstairs one. So if there was something wrong with the coil on this one, we would be able to isolate this unit and basically have the whole system still running while working on that one system.
We have two branch boxes.
Yep.
And these are essentially tied to your outdoor units, the outdoor heat pumps.
Yes.
So your line sets are running from the heat pump to your branch box. And then across these two, there's 4 here and 3 here, which make up our 7 indoor units.
Yes.
So if my kitchen has an issue,
Yep.
you can come in, shut my kitchen off.
Yep.
You can when you're talking about your recovery, you're talking about recovering the refrigerant.
Pulling the refrigerant right out.
Because that's important. Like you have to capture that when you're working on the system.
Yep.
And you can work on that while the rest of the home, the other 6 zones, are heating or cooling the home.
Yes.
Say if you have to shut that down for an extended period of time, now you're able to allow the home to passively heat and cool that zone through the other units and not run that risk. A great detail, I think, that made a lot of sense once I saw it installed. This is for our condensate. What is condensate?
So our condensate is just basically the moisture in the air being removed. Basically dehumidifying, but dehumidifying is just a byproduct of cooling. We actually put a T in right here, so that way, again, for our service guys, when they come here and they do a PM, they can just pull this right off, put their nitro in and blow it right out and put it right back on.
Just pressurized nitrogen?
Yep, pressurized.
Sorry, I went right to nitro coffee.
Yeah.
And I'm like, hold on, you got to just explain that to me.
So dry nitrogen is what we use to really push and clean like these P-traps, because over time this P-trap will get, built up dust, debris, anything, and it'll kind of sit there. So normally we like to put a little, we call it a clean out, and we would just put it so that way it will blow out and blow the P-trap right after.
And what is this one here?
So that is a vent. So just like any other plumbing, when this pipe is filled with air, when water starts going through it, the air being replaced by the water has to go somewhere.
Got it. And these ones appear to run in this direction. So where is this ultimately gonna to end up?
It's going to end up to a condensate pump to where we will pump into the main drain of the house.
And we're heading in that direction because we have
a condensate pump from the
water heater. We're working with other trades, the plumbers. We could have easily allowed them to do their thing and we would have ended up with 2 condensate pumps.
Yes.
Rather than saying, hey, you need one and I need one, we can use one together and get it back to an open air trap. Which I think the open air trap is here, which is just tied up to what your units upstairs are draining into.
Yes.
The other thing in here, this is number 1 of 2 Zenders. Zender is what I've described as the Cadillac of fresh air.
Yes.
I think I'm not the only one that has said that, but essentially this is an ERV. Energy recovery ventilator, different than an HRV, where the difference is that this exchanges the humidity and the temperature versus a heat where it's just the temperature. Is that right?
Yes.
Why are we working with the Zender versus another unit?
With the Zender, it's a whole house. You're actually just taking the stale air now and you're dumping the fresh air right into the house. Other ERVs, you would connect them to your air handlers to where you would be mixing the fresh air and the stale air.
What you're saying is that this goes up to, are these branch boxes as well?
These are manifolds. These are the supplies right here, and these are the returns.
You can actually see bedroom 5 supply. So that brings it up to bedroom 5, but directly to the bedroom.
Yes, directly to the bedroom.
And that's what you mean by whole house ERV, is that it's direct fresh air to the space.
Yes.
And then here you're taking stale air typically out of the bathrooms, the laundry room, kitchen, spaces like that, right?
Yes.
If you're new to ERV systems, the key here is that you're taking the stale air out of the home and you're replenishing the entire home with fresh air. You're bringing outdoor air and you're filtering it. Not beyond the core, there's actually filtration as well,
yes,
pulling out any of the contaminants. So when you're bringing that quote unquote fresh air from outside and you're putting it into your bedrooms, it's truly filtered fresh air. You know, a lot of people talk about like, oh, we're building homes too tight, the house needs to breathe. This is the lung. And this is one of 2 lungs that we have in this home, but this is the lung of the house where it's, you know, rather than allowing the walls to leak or the doors to leak or the windows to leak or windows to be open and bring in fresh filtered air. And that's the key to this system. But we have one more ERV down here. So we are on the other side of the home right now. This is what is considered kind of living room number 2.
Yep.
And we have another Zender Comfort Air. So walk me through why we have another one.
The house is so big and we do have maximum line lengths with our system.
So this can only run so far. Do we know what that length is, or is that?
I think it was 150 feet is what we could do.
So one of these can run up to 150 feet. So when you go beyond that, I think what's important to note is Zender's really strict.
Yes.
But they're strict at how their system operates because they want it to be the best.
Yes.
So that's really what demanded us to have a second unit here.
Yes.
This is your...
That's our controller.
And this is just like a status light or something?
That's what we can hook the Wi-Fi up to, like hook up your phone to.
I kind of alluded to the fact that this is just bringing fresh air in, but it's more controlled than that. There's actual switches upstairs. There's, I think we call it a boost switch.
Yep.
So this is this passively running at all times? And when are you activating, say, a boost switch?
So basically it's running at its low speed at, most of the time. And then when you go into the bathroom or take a shower, there is a switch there that you'll hit it and it will actually go into like a high speed for about 20 minutes.
Is that boosting the whole system or just dedicated to that one spot?
No, it's boosting the whole system generally.
So it's, you know, it's essentially wherever this is pulling air from, that everything gets pulled out at a faster rate, runs for about 20 minutes, and goes back down to low speed. I also heard it's great for parties if you have a lot of people over. There's a lot of hot air coming out of everyone chatting, but it's not a bad idea to hit that boost switch and just keep the fresh air and you know, pumping in there. I think this is a similar approach that casinos take. They pump in a bunch of fresh air so you stay there longer.
Oh, yes.
So you get people to stay at your party longer by bringing fresh air. We had the 2 typical air handler units in the mechanical room, but we tucked in what is called the pancake units. I guess one question that's probably going to come up is like, why not just use all of these? Are these more expensive? Are they can't run as far with ductwork? Like, why wouldn't you just use the small units everywhere?
We mainly want to use this system when we're kind of just doing one room or something like that. Like with
these have less of a capacity. Those can provide more air to bigger spaces.
Yes.
Got it. And this is really handling our living room upstairs and then our basement down here. And the nice part is they are small and we could still get a ceiling in this space as long as we give you the adequate access
Yes.
to do your mechanicals. Mike, I appreciate you walking through the mechanical room. Now, as you can see, there's a lot that goes into a project like this, a lot of consideration, a lot of planning, a lot of pre-construction discussion around this. HVAC is something that can be more complicated, but with the right team and the right planning and, frankly, the right engineering, you can build a system that is not over-engineered, that is designed exactly the way the home requires it to be designed, and provide a really comfortable living space. And that's really important to us and to all of our projects. And if you're interested in building a project like this, fill out the form below. If you're a builder that you want to learn a little bit more about how we do what we do behind the scenes, join our Modern Craftsman newsletter. The link is below. We'll see you next time.